Hi everybody. Today we're going to go over polynomial inequalities. Now we are a little bit done with polynomials. We're into rationals, but we're going to go backwards a tiny bit and do some inequalities. So here's just some graphs of some polynomials. Nothing too fancy, but to read the graph, to figure out, well, where is the graph less than 0? Obviously that's below the x-axis, so we would just look at, so this basically is the graph. So where is the graph less than 0? Well, here's where it equals 0, and it's less than 0 all down here, all the part that hangs below the x-axis. Well, this would be from -3 to 1. Right? So x is between -3 and 1. Because this is an open circle, the reason it's an open circle on the graph is because this does not have a line under it. And since there's an open circle is a rounded parentheses, we want to put this in interval notation. If you had more than one section, you would just make a union of all of those sections. So if we take a look at this one, we'll make it a little bit bigger. We want to take a look at where is the inequality greater than or equal to 0. Well, we've got 3 places where it's equal to 0. And you can see it's greater than 0 from here to here. So here on the x-axis, we're looking for our x values. And then it's greater than or equal to 0 from here over. So basically all of these x values. So if we interpret this a little bit, the graph is a little bit hard to read. We'll call that -5. This is going to be a squared bracket because this has a line under it. And it stops at -2. And then obviously -2 goes down below 0. And then it picks back up again at 0 and goes to infinity. So these are really easy to solve when there's a graph. When there's not a graph, or you cannot create a graph, we have a few more steps to follow. I don't know why that's floating around. Let's see if I can get rid of it. So we're going to, first of all, we're going to factor out our inequality. So we are going to basically set this thing equal to 0. We kind of ignore the inequality until the very, very end. So you find out where your zeros are. We'll put these zeros on a number line. We're going to test a section, evaluate what's happening on each interval of our number line, and then, of course, rewrite this in interval form. So this first one's already factored, which is nice because it makes it a little bit faster. And we have some answers already. We know that a equals 2 and that a equals -4. Well, these are the values that go on the number line. And just like we did up there, since this has no line under it, these will be open circles. Please make your number line make sense. -4 is to the left of 2. -4 is smaller than 2. I'm going to pick a value that's not currently on the number line. I'm going to pick x equals 0. X equals 0 lives right here. You don't have to pick x equals 0, but whatever you pick, make sure you put it in the correct spot on the number line, and you cannot pick the numbers that are already on the number line. So if I put x equals 0, I'm going to put the 0 right back in here. Now I'm going to go to the original problem, which includes the inequality. So then I get -2 times 4 is greater than 0. Well, that's -8. -8 is not greater than 0. This is not true, which means this section, and all the numbers in that section, do not work, which means the other two sections do. So we're going to always go, it's going to look like this pattern, yes, no, yes, no, yes, no, all the way down the line. Now you do have to translate this into interval notation. So this would be -infinity to -4, both rounded. And then we would join that up with 2 to infinity. Really the only thing missing from that one was factoring. So to factor it, it just adds one step. So let's factor this. So when you factor it, we're going to actually set it equal to 0 and kind of ignore that inequality for a minute. Multiply to get 15. And when we subtract that, we need a +2. So our solutions are x equals -5 and 3. Let's put these on the number line. Now these will get a solid circle because there is a line under the inequality in the original. Again, we have to pick a test point. Might as well pick 0. X equals 0 happens to live right there. Put it back into the original. This original is a little bit easier than that first one. We'd end up with 0 plus 0. So we end up with negative 15 is less than or equal to 0. Well, yes, that's true. So if this one works, then it goes no, yes, no, and it alternates like that all the way down. So then this as an answer is simply negative 5 to 3. That closed circles give squared off bracket. Again, remember all the factoring that we've recently done, anything can happen. If you get imaginary answers, imaginary numbers, you cannot graph, so you ignore them. X to the fourth needs to be factored. X squared times x squared. Multiply to get 9. Add to get 10. So 9 and 1 will give you 10. So here we get x squared minus 1 equals 0. So remember, you get a positive and a negative when you take the square root. So x squared equals 9. So we get x equals plus or minus 3. So we have 4 numbers on the number line. Put them in the correct order. So we have negative 3. That's the smallest number. Then we have negative 1. Then we have positive 1 and positive 3. Now there's a line underneath this inequality, so all of these are solid, which translates to squared off brackets. And again, I'm going to try to pick x equals 0 because I do think it's the easiest number to plug back in. So when we do that, we end up with 0 minus 0 plus 9. Is that greater than or equal to 0? So 9 is greater than or equal to 0. So this is a yes. So again, remember, it's going to go every other. No, yes. So yes, no, yes, no, yes. I like to color it in on my number line because then I don't really have to think too much about it. And now all I have to do is read the number line. So this is going to be negative infinity to negative 3. This will be joined up from negative 1 to 1. And then again, another section of the graph is 3 to infinity. This is the same way you write the intervals in ALEKS. And for this last one, first thing we have to do is get it set equal to 0. So we'll bring this 3x squared over. Also, we're going to bring the negative and make this 32x negative, and the 48 stays positive because it's not moving. Set this equal to 0. 4 terms is grouping. First two go together. They have an x squared in common, leaves you with 2x minus 3. Force that 2x minus 3 to happen. Those should take out a negative 16. Get us 2x minus 3 again. Now they have a 2x minus 3 in common, and the other factor would be x squared minus 16, just reading the front numbers from left to right. So here we get x equals 3 over 2, and here we get positive and negative 4. So we have negative 4, positive 4, and of course 1 and 1/2 or 1.5, 3 over 2 lives in between there. I'm going to test x equals 0. Luckily that's happened every time. If you can't pick 0 because it's on the number line, 1 obviously is a good number as well. And so when we put this back into the original, it's 0 plus 48 less than or equal to 0 plus 0. And again, anytime there's an x, that's a 0. So these would all be zeros. So basically, is 48 less than or equal to 0? Well, no, it's not. So it goes yes, no, yes, no. There is a line under the symbol. So these are all colored in circles. And we just need to write the answer in interval form. Just need some more space here. So we're going to have negative infinity to negative 4. We're going to join that with 3 over 2 to positive 4. So go ahead and do the assignment on the back, and we'll go over that the next time you come to class.